All right. So we're going to start on lesson 1.3. We're actually skipping lesson 1.2 here, but there's one big piece of vocab that I just want to mention and go over a little bit, and that's the word congruent. So as we get into geometry, we're going to be talking a lot about geometric objects. That in general means anything, point to plane. Think of it like something you draw or something you can hold in your hand, like a line or a plane, a sheet of paper, or a triangle that you cut out of paper, or an object that you could hold that you'd refer to, something in geometry that is not a number, right? It could have a value, like the length of a line segment could be 5, but as we start talking about geometry, we'll be talking about the actual line segment itself, so an object, a geometric object. And we can't have those be equal. All of algebra is based on numbers and placeholders for numbers, or variables. But now that we're in geometry and we have geometric objects, we need a way to talk about how they're related. We'll get into similarity later on, that's chapter 6. But the word congruent means two geometric objects. So, right, geometric objects being all the things we're talking about in this book. But two geometric objects that are exactly the same in every single way except for name, right? Obviously, one line segment could be named AB, and the other could be named CD, but if they're the exact same length, height, width, etc., they're exactly the same, other than their names, so we say they're congruent. Now, I brought up that example of a line segment. Oh, here, let's talk about the symbol really quick before I go back to line segment. So in writing, like when I would say like, oh, triangle, that's a terrible triangle, ABC is congruent to triangle DEF. That means they're really the exact same triangle. I just erased the names and named it something else. Maybe I picked it up, turned it around, put it in a different place, but it's the same triangle. Every measurement is exactly the same, whether you measured an angle, a length, an area, anything about it. Or you could just show it in pictures, so without words. In a picture, what it looks like is we'd have some number of dashes on something, and then the same number of dashes on the same geometric object somewhere else. So this could be on side lengths, this could be on angles, this could be, I don't know what else, usually it's side lengths or angles. But this is saying that this line segment right here is exactly the same as this line segment down. Okay, and I can tell that two dashes matches with two dashes, and a single dash matches with a single dash. Okay, now congruent line segments, since line segments only have one dimension, they only have, other than their name, they only have one attribute. That attribute is a length. There's no thickness, there's no height, there's no color. It's just from this point to this point is 4 inches long. And it doesn't matter where in space I put that or what I name it. It's still the same as every other 4-inch line segment in the universe, right? No matter where it is, no matter what color it is, there is no width or, etc. So for two line segments to be congruent, that simply means they have the same. All right? So now we're going to jump into section 1.3. I just wanted to mention that idea of congruency. And right here, here's an example. If we have that they're congruent, then this means then the length of AB, which we'll go over this symbol later without a symbol above it, we're talking about the distance from A to B, the number, that's equal to the distance from C to D. So in other words, the length, I missed a G somewhere in there, of AB equals the length of C. So the two lengths are the same if they're congruent. Okay, so let's start with 1.3, which is all about midpoints and distance formula. Okay, we're going to look at it geometrically and then also algebraically, like on a coordinate plane. Hopefully that's a review from algebra. And then we'll show you that it's the same in geometry. We're just going to take away the coordinate plane and instead deal with a simpler diagram. Like just, here's from point A to point B. What's a midpoint look like? What's the distance look like? Okay, so first, the midpoint. That's the point exactly in the middle of the line segment. Now, you might see the word equidistant. That simply means equally distant. Okay, so equidistant from the two endpoints. The endpoints, right, are A and B. Those are the endpoints. So if it's equidistant from both of those, and I put a little asterisk because we need to be really clear about this. Now, there's lots of points that are equidistant, right, from A and B. This is maybe 10 and 10. So there's more than just one point that are equidistant. So that's why I wrote over here on my line segment. So the point on the line segment that's equally distant from the two endpoints, that's another way to say it. Okay? So in this picture here, you notice that that point in the middle M is 4 inches from each side. So this is the midpoint. And then over here on the right, I see the red dashes telling me those two lengths are congruent. So that means that M is the midpoint. Okay. So that's what a midpoint is. We haven't solved anything using it, but that's either with numbers showing it's in the middle or with dashes showing that left and right are congruent. Now, a bisector is anything that goes through that midpoint. So anything that cuts it in half into, say I have a line segment that's 8 long, anything that cuts it into a 4 and a 4, bisector. You could use it like a verb, so that right bisects, this line bisects, or down at the bottom you could call it a bisector. So either as a verb or a noun. So right here I gave 2 different examples because this is anything that passes through the midpoint. I mean, if we're talking about 3D space, you could even have like a triangle turned on its side so it's razor thin, and that triangle cutting it in half. So you could have any object depending cutting this in half, okay? So bisects really means cut into 2 congruent parts or 2 equal parts. So ray AB bisects NN, and I can tell from the picture. I can see these 2 lengths are congruent, so this must be the midpoint. And if AB goes through the midpoint, it's cutting into 2 equal parts, so AB, that ray does bisect. Okay, over here, I showed you the same thing. Again, this is with numbers. So those 2 equal lengths mean this is the midpoint. And anything passing through that midpoint doesn't have to be perpendicular. As long as it passes through that midpoint, it's cutting that line segment QB into 2 equal parts, or it's bisecting line segment QB. All right, so those are our 2 big vocab words, midpoint and bisect. Okay, and then I'm going to make one really important note here. This is just a common mistake as we're introducing language. This is a really important distinction to make. And a lot of people don't grasp this, and then they just get mucked up on what a question's even asking. So when you see an AB with no symbol above it, and an AB with a symbol about it, those are totally different things. AB with no symbol above it is a number. You can use algebra, right? This is when you'll be like solving for a length. You'll be, 2x plus 5 equals something. That's with AB, which is the length of line segment AB. So that would be like 7 inches. Whereas down below, AB with this line segment over here, that means we're talking about now the actual line segment. I could pick that line segment up in my hand. I could walk it somewhere else. I could erase its name and change AB to be named CD, but it is the actual line segment that we're talking about. Okay, so the big difference is the top one is a number. It's the length of the line segment, and the bottom one is a geometric object, and it represents the actual line segment. Okay, now examples is, I forgot to mention this. So anything that's equal, we use algebra, it uses the equal sign. And any geometric object, if they're the same, we'll be using the congruent sign. So down here, I gave an example. Because I see that these 2 measurements are the same, and I know that for a line segment, as long as they have the same length, then they're the same every single way but name, so we say they're congruent. So over here, we could either say that the length of QI is equal to the length of YB, or you could say that the length of QI is equal to 10 meters. Either one of those totally okay, equal signs, length, or you could talk about the object. You could say the actual line segment, QI, is the same as the actual line segment, YP, and that's when you use the congruent sign. Oh, and not down here, you can't have a number of congruent to another number. That just doesn't make sense. Just, clearing up what's a geometric object and what's a number. Okay, so here's the type of question. And this is going to be on the first quiz when it says, first quiz on geometry. When this says find AM, a lot of people don't even know what that means. They'll come up to me during that quiz. What's AM? What do you mean, Mr. Dilloughery? And I'm like, oh, sorry, like that's a geometric term. You should know what that means. And so I won't answer that question on the first quiz when that comes up. So when it says find AM, it really means find the length of line segment AM. Okay, so let's see. Well, right now the length of it is just x plus 5. So I mean AM is equal to x plus 5, but I'm pretty sure they want us to find not just an expression for it. I think they want us to find the actual value. And so what can we do? Oh, well, I notice there's a dash and a dash, so these must be the same. So, well, let's do it in order from left to right. So we got x plus 5 must be the same as 2x. That's where that first step is geometry, and now the rest of the problem is algebra, right? I had to interpret the question in the picture, and now that I've set up that relationship, the rest of the problem is algebra. So let's move all the x's to one side. We get 5 equals x. Is that what the question was asking? No. AM is x plus 5, so AM is equal to 5 for x plus 5, so the length of AM is 10. Okay, I will do another one, but it's the same. The key is I noticed that this is equal to this, so right away I could set up, without even knowing what the question's asking for, I could set this up and I could solve, and algebra, you get x equals 6, and then you see what's the question asking. The question is saying find EM, which means the length of EM. So I would plug x equals 6 back in here, and I said I wouldn't do it, but gosh darn, I did it. So we get 42 is the length from E to M. Okay. So now we talked about what a midpoint is, but now we're going to give you the actual formula. So what if we go to the coordinate plane? How do we find the midpoint when we know their actual locations in terms of coordinates? So there's a formula here. You could absolutely memorize that formula, but I like to think about it in terms of big picture. I find that easier to remember than letters and numbers and specific order of place. So for me, the big picture is the midpoint's just halfway over and halfway up. So in my picture, if I was going over, oh, let's do this in a bright color, like bright pink. In my picture, if I was going over 10 and up 5, then my midpoint would be over half of that, 5, and up half of that, 2.5. Because if I go over another 5 and up another 2.5, I'm at the other end point, right? So exactly half is halfway right, because I'll go the other half later, and then halfway up, and I'll go the other half later. So halfway over, halfway up, midpoint. And then the rest of the way over, rest of the way up is the other half. So that's the way I remember it. Or you could just remember for the formula, the midpoint's simply the average of the endpoints, right? The average of two numbers is a plus b divided by 2. And that's what we do. We take the x plus the x and divide it by 2. And then we take their y's, add them up and divide by 2. So it's the average of their x values, aka halfway between the x's, and it's the average of the y value. In other words, halfway between the y's. So you can conceptually use it. Like if I say find the midpoint on a quiz, take out a sheet of graph paper and just count. That's a 100% valid way. It's the ninja of using what's around you. That's great. Or you could just plug the formula. Totally okay. Either way, traditional, conceptual, they're both awesome. Okay? So let's do it, okay? So here's find the coordinates of the midpoint. So first let's just plug in the formula, okay? So midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay, so I'm going to name this point xy and this point xy. Now people get confused with what that 1 and 2 mean, okay? That the one down below is called subscript. Subscript meaning literally writing below, right? So a subscript down below, that is no mathematical value, right? This isn't saying x squared. This isn't saying x to the 1 power. It's a naming convention. All it's doing is saying, okay, well, out of these 2 points, I have to be able to distinguish between the x's. So let's call this one point 1, and let's call this one point 2. Simply named. No mathematical formula value. Okay, so then what I do is I just plug it in. So down here, that would be x1 plus x2, that's 3 plus 7, divided by 2, comma, y1 plus y2, so 5 plus 5, divided by 2. So without any conceptual reasoning here, just using the formula, I get 10 divided by 2, 10 divided by 2, or 5 comma 5. So my midpoint is at 5 comma 5. Alright, so now let's do it a little more conceptually with the next problem here. And give me a second. There we go. It's just jammed. It wouldn't let me move. Okay, so this one I'm going to do conceptually, okay? So I'm going to just create a quick graph here. And I'm going to say 1 point's at 0, comma 4. 1, 2, 3, 4. Okay, there's E at 0, comma 4. And then I've got F at 1, 2, 3, 4 at 1, 2, 3. Okay, so there's 4, comma 3. So what I'm going to do really quick is I'm going to say, okay, what's halfway between those? So between 0 and 4, halfway over instead of going 4 is I go over 2. Okay, so halfway over is 2. And then instead of going down from 4 to 3 and going down 1, I'm going to go down a half. Right, so down 0.5, and then the rest of the way is going to be going over 2 more, and down another 0.5. That's the total journey, right? So over 2, down a half, over 2, down a half, and I did the whole journey. So this point then would be 2, comma 3.5, right? So I like doing it conceptually like that, but you can absolutely do it however you see fit, okay? So that's the midpoint. Have a formula. You can use the formula. Same thing with distance, okay? There is a formula. Again, though, I like to remember it conceptually. There's this fancy formula. It's the same thing if you have a first point and a second point. Again, it's just xy with a named point 2 and xy with a named point 1, okay? Well, you plug it into this formula, order of operations, square it, square root it, etc. I like to think of it, though, as this is really just the Pythagorean theorem. All they did is say, how far did I go over, A, and how much did I go up, B, or B. And you know left and right and up and down on a coordinate plane, the x-axis and the y-axis are perpendicular, so it's got to be 90 degrees between x's and y's. And so, a squared plus b squared equals c squared. That's all this is. Here's a squared plus, here's b squared, and instead of saying equals c squared, we just took the square root of both sides. So they said c equals square root of a squared plus b squared. Because when you subtract the x's, you're just saying what's the difference between the x's. When you subtract the y's, you're saying what's the difference between the y's. So I like to think about it that conceptually. You don't have to. Okay? Absolutely, there's just a formula to use. So let's do an example. Here's this one. I'll just use the formula. Okay? So formula says I'm going to call this one my xy 1 and 1. I'm going to call this my second point, so xy with 2. Okay, so this is square root of x2 minus x1, so 5 minus 1 squared, plus y2 minus y1, so 4 minus 2 squared, plus the square root of 4 squared, plus 2 squared. I got rid of the parentheses since there's no negatives. That's square root of 16 plus 4. Now notice, this horizontal bar on top means I have to do everything inside before I do the square root. So this is not equal to 4 plus 2. I can't take the square root of 16 square root of 4 separately. Okay, so this is instead the square root of 20. And as we don't have calculators, we're going to stop there. Yes, it could be simplified. We haven't gone over that. We'll specifically do that in chapter 7. But if you would like to simplify it, great. You're done there. But if you want to simplify it, you could say that's the square root of 4 times the square root of 5. Just that's the same product. And then that's 2 root 5. If you wanted to, you don't have to. Alright, so the next one, I'm going to do it conceptually. I didn't like that whole formula stuff. So instead what I'm going to do is I'm going to say if I want to find that distance, I'm going to say count over 1, 2, 3, 4, 5. And count down 1, 2. And I know that's a right angle. So my distance squared, or let's even do it this way. So my 2 squared plus 5 squared is equal to my hypotenuse, or distance squared. So that's 4 plus 25 is d squared. 29 is d squared. So d is taking the square root of both sides, square root of 20. And again, We're not going to go any further because we don't have a calculator. That's it. Now you might have to plug it into a calculator to check your answer in the textbook, but that's how I would like your answers on a test or quiz, seeing as you don't have a calculator. All right. So now I'm just going to go over some of the harder homework problems. That was the full lesson. Okay, so a couple problems. Describe the error made in finding the coordinates of the midpoint. And this is a really common one. People mix up the two formulas here. So when we want to find the midpoint, it's the average of the x's and the y's. You add them together and divide by 2. And yet in the distance formula, you want to know what's the difference between the x's, because that's your A, and the difference between the y's, because that's your B. So in one formula you're adding, one you're subtracting. It's really common that people get them mixed up. So here, to find the average, they should have added, but instead they subtracted. Really common mistake, okay? If you just change that to plus and change that to plus, they did do x's together, they did do y's together, everything about the order was correct. We just switched this on. Okay, so use the given endpoint, R, and midpoint, M of RS to find the coordinates of the other endpoint. So what they're really saying is, here's RS. I'm going to give you the midpoint M, so I know these are equal. So you have R and M, find S. Common mistake here is people just plug R and M into the midpoint formula and say the answer is, and they'll find the midpoint here. That's a quarter of the way. It's halfway between R and M. They'll find this, but that's not what we're looking for, right? We don't want to just shove R and M into the formula. We got to be a little more clever. Now we can use the formula, but we don't just plug it in like we used to, right? Think about it. The midpoint is equal to the average of the x's and the average of the y's. So if we want to use the formula, we plug the midpoint into the midpoint. Oh, dang, little battery. We plug the midpoint in here. I mean, that's correct. That's where the midpoint goes. Equals, and then we plug our first point in to x1 and y1. So we've got 3 plus something divided by 2, comma, 0 plus something divided by 2, and we're looking for the second point. Now that's totally a valid approach. You can just use the formula. It doesn't matter whether you plug in the 2 points to find the midpoint, or plug in a midpoint and a point to find the other. It's still sufficient information. So the way to do this, the best way to do is to say, well, I know my x has to equal this, and I know my y has to be equal to others, so I'm just going to split those up. 3 plus x over 2, or x sub 2 over 2 equals 0. So multiplying by 2, 2 times 0 is still 0, so 3 plus x2 has to be 0, so minus 3, minus 3. So x2 is negative 3. And then over here, 0 plus y2 over 2 is equal to 5. Now I don't need a 0 plus. It's really y2 over 2 is equal to 5. So multiplying by 2, I get y sub 2 is equal to 10. So my point was negative 3 comma 2. And if I want to check, I could just say, what's the midpoint between this and my original R? Is it the midpoint that I want? Okay? However, I'm going to do it conceptually again, because I like thinking about things conceptually. It's not even that, I mean, it does make more sense to me, but it sits in my brain easier. I can more easily remember the y than I can remember the beep boop bap boop a to b to the second to the minus 14. That's harder for me to shove into my brain. Whereas when I hear the y, I go, oh, that's so much easier. And that's the way that it stores for me. So here we go. Let's go. This is 5, 1 here, and 1, 4 here. So this is my midpoint, and this is my R. How will I find my S? Well, let's think. If this is halfway over, I went over 1, 2, 3, 4. So I went over 4, and I went up 1, 2, 3. So I went over 4, and I went up 3. And that's halfway. Well, if I want to go the rest of the way, let's do it. I'm just going to go over 1, 2, 3, 4 more, right? 1, 2, 3, 4 more. And I'm going to go up 1, 2, 3 more. Because, right, the M is halfway between. So if I go over and up a certain amount, that's one step. I just need to do one more of the same step, right? So then that lands me at 1, 2, 3, 4, 1, 2, 3, yeah, right here. So the answer is, we're looking for S. The answer is -3, 7. So I find that to be much clearer, but it's totally up to you which way to do it. They both get you to the answer. Okay, so the last one, this isn't so much difficult as just clarifying what it means. It says find the length of the segment. So that's straightforward. If I want to know what's the length from here to here, first I need to find the pattern. Okay, if this is going 2 squares for every 2 units, well then each of these must be 1. So here's a 1, a 3, a -1, a -3. So I'm going from -4 to 3. You could literally count, but the other way to do it is to subtract. You just go 3 minus -4, the bigger, oops, I put the parentheses in the wrong spot. 3 minus -4, the big minus the small, and the difference of those is 7. Okay, so this is a distance of 7, that's the length. So you could, oh, there's no name for these endpoints. So otherwise I'd say the length of, but I don't have a name, so we'll just say it's 7 long. And it says find the coordinates of the midpoint. So where's the midpoint? Well, if it's 7 long, then 3.5 from either edge, half of that, is where the midpoint is. So we go over 1, 2, 3, and a half is right here. So the midpoint is at -0.5. That's the location on this map. Now you're used to talking about location on a 2-dimensional coordinate plane, where you're saying the location of this is 5 to the right and 6 down, right? But that's not what we're doing here. Instead, we're saying, what's the location on a 1-dimensional? So all we have is X. The location on the only X map is X is -0.5. Okay, so instead of a 2-dimensional X and Y, it's just a 1-dimensional, you just say its location on there, and the X value is -0.5. All right, that's it. I hope you enjoyed the video. Good luck.